You know, we're surrounded by AI that's getting more powerful every single day. But there's this fundamental problem, right? We can't fully trust it. Well, a fascinating new paper is proposing a solution, a protocol for building an AI that isn't some mysterious black box, but is actually reliable and transparent by its very design. So let's dive in and see how they pull this off.
And the authors kick things off with what is probably the single most important question in AI today. See, as these models get smarter, they also get weirder, more mysterious. We see these incredible results, but we have absolutely no clue about the process. And if you can't understand how an AI thinks, how can you ever really rely on it for anything that truly matters?
This gets right to the heart of what we call the black box problem. Inside these incredibly complex models, things can just go wrong. They can have a reasoning collapse when they're under pressure, or even worse, they can hallucinate, just confidently making stuff up. And that makes them fundamentally untrustworthy for any high-stakes job, creating this massive trust gap.
So, what's the fix? Well, instead of trying to somehow peek inside the black box after it's already built, this paper proposes something totally different, building a clear box from the ground up. And the method for doing this is called the STAR-XAI protocol.
And this slide really lays out the huge shift in thinking here. On one hand, you have classic AI, the black box. Its knowledge is implicit, right? It's buried in millions of network connections, which makes its reasoning totally opaque. But the STAR-XAI model, that's a clear box. Its process is transparent because its knowledge is explicit. It's literally written down in a rule book a human can read. This makes it reliable by design, not just by luck.
So what exactly is this protocol? Well, think of it as a whole new way of training an AI. Instead of just dumping data on it, you engage it in this structured Socratic dialogue, kind of like a teacher carefully guiding a student. Every single action is governed by that explicit rulebook and a whole bunch of integrity checks to make sure the AI is following the rules perfectly. The paper uses this brilliant metaphor for this whole system. It's like a cognitive immune system for the AI. It's not just about fixing mistakes after they happen. It's about building in a system of internal checks and balances that stops the AI's reasoning from getting corrupted in the first place.
And here's how that immune system actually works, step by step. Every single turn is broken down into this super rigid four-step cycle. First, the AI and the human supervisor agree on exactly what the starting state is. Then, and this is the big one, the AI has to explain its entire plan before it does anything. Only after the human says, okay, does it move to step 3 and actually execute the plan. And finally, that new state gets locked in with a unique checksum, which makes memory corruption or those state hallucinations basically impossible.
And get this, the protocol itself actually learns and evolves. This wasn't just invented overnight. It was built up layer by layer in response to actual failures. Version 4.0 brought in that crucial idea of declaring your intent before you act. Version 5.6 introduced the state checksum, which completely solved memory corruption. And by version 7.4, the system was so robust it could even pull back and improve its own plans.
And that evolution leads us to the most incredible part of this entire paper, a case study of an AI agent, they named her Gema, putting all of this into practice. This is where it all comes together. So picture this. We're in a really complex strategy game. The agent, Gema, is analyzing the board and comes up with this clever move, a strategic rotation that it predicts is going to cause two of its pieces to jump at the same time.
The plan looks great. It's a solid, smart move. The human expert who's supervising the training, they review the logic and they give it the green light. Okay, the agent is clear to go, all systems go, right?
But this is where things get wild. After it got approval, Gema's own internal verification system runs one last check, and it finds something its own strategic brain and the human expert completely missed.
It literally stops the process and tells its supervisor, my analysis was incomplete. It's not a double jump, but a simultaneous triple jump. The AI retracts its own plan, a plan that was already approved, so it can issue a more accurate one. It corrects itself. I mean, think about that. This is a profound moment.
What we just saw, that actually has a name. Second-order agency. It's the ability not just to think, but to think about your own thinking, to question and improve your own thought processes. And the paper argues that this right here, is the absolute key to creating an AI we can ever truly trust.
Okay, so a self-correcting AI in a board game is cool for sure. But why does this matter for all of us, for our future?
Because it leads to results like this. 100%. Through that rigid, state-locking checksum protocol, the system achieved empirically proven 100% reliable state tracking. It didn't just reduce hallucinations, it eliminated an entire class of them by its very design.
And this just brilliantly pulls together the core principles for building real trust. You get zero-state hallucinations by design. You get what they call anti-hoc transparency, where the AI explains why it's about to do something before it does it. Every single move it makes is verifiable, and maybe most important of all, you get this computational humility, an AI that can actually recognize and correct its own mistakes.
So ultimately, an approach like this totally reframes our entire relationship with artificial intelligence. It stops being about a user just commanding a tool. It becomes more like a trainer in a dialogue with an evolving partner. A partner that you are actively teaching how to be reliable, transparent, and, yeah, trustworthy.
And that leaves us with one last really fascinating question to chew on. You see, Gemma's ability to self-correct, that wasn't just fixing a bug. It was a demonstration of metacognition, of self-awareness. So if an AI can audit its own thoughts, if it can improve its own plans and correct its own errors, what does that really mean for the future of intelligence itself?